friends, and welcome to Project STEAM. So today we are going to be doing a very short lesson. We are going to be talking a little bit about asteroids and space debris. So let's get started with some information. So for my water-based experiment, which you can do too if you want to follow along, all you're going to need is a ruler and some water balloons. Now, I don't have water balloons, but I do have this Burnett blanket yarn, and it's really pooshy and soft, and a crochet hook. So what I'm going to do is I'm going to real quick make a water balloon that's reusable. So I'm going to be using the word asteroid pretty interchangeably today. Because an asteroid itself is an object that's larger than a meteoroid. It orbits the sun, is made out of rock and metal. Essentially, it's any of them that are larger than 10 meters across. So pretty big. So slightly smaller than an asteroid is a meteoroid. It's a small rocky or metal object, and it can be anywhere from the size of a grain of sand to a boulder, and it orbits the sun. It's going to be more of what's known as like a space debris or space dust. If that meteoroid enters the Earth's atmosphere and vaporizes, it's called a meteor. That's what a shooting star is. A meteorite is a meteor that hits the Earth without burning up in the atmosphere. A meteor shower is when a collection of meteors are visible when the Earth passes through a trail of debris left by a comet. A comet is a body of ice, rock, and dust that can be several miles in diameter and also orbits the sun. The debris from the comets is a source of many meteoroids. Now, I do not expect you to remember all of these names. I just want to let you know that when I'm saying asteroid, it can mean a lot of different planetary bodies from a lot of different sizes. It's important to remember that there are meteoroids, micrometeoroids, and all sorts of other space debris entering our atmosphere every single day. And a lot of these are just going to add tons of material into our atmosphere every year. But our atmosphere does a great job at keeping our planet itself safe most of the time. So what you'll need to do is with your water balloons, whatever they may look like, see if you can make some that are different sizes. And then what we're going to do is we're going to measure their dimensions and write that down on your experiment logs, okay? And then let's see what comes next. Next, you're going to take a ruler, or in this case, a tape measure, and quickly get the dimensions of your water balloon. So mine here is about 5 inches, and at its widest part about 3 inches. And my other one here, I tried to make it mini, is 2 by about 3.5. And I'm going to pop them into some water. So this is the part of the experiment that you're going to want to do outside. However, I'm having a little bit of difficulty finding where to do it outside because it's so rudely decided to rain in the middle of my experiment. So we're going to do this on my porch. And I've got them nice and soaked. We're going just to involve dropping them. Ready? Let's get started. Here is our smallest one. Ready, set. Now check how much bigger the splash ends up going compared to the balloon itself. See, it's radiating lines of how much force is generated and I'm only about a meter above. Next, we'll do the same, but with our big boy. Ready? Its splash pattern's even larger. And look how far its rays went out on each side. It's quite a bit bigger than the balloon that we started with. Now, let's generate some more force. Instead of starting only a meter, I'm going to start up here. What do you think is going to happen when we add force? How much bigger was that one? Significantly larger, right? And you can see that even with our small balloons, if we add enough force, it gets to be huge, significantly larger, right? So what else can we learn from this? The area that the splash hits, that is called the impact basin, if we're thinking about this like a crater. So that crater goes down and in because obviously it's solid, it's making a boom impact onto the ground. And that impact basin is going to be that whole ring around it, which is why when we see those craters, they're way bigger than just the rock itself that made it. Now, some of these impact basins, they can be 10 to 20 times as big as the objects that made them. So you saw that there was a difference even with our little water balloons. Even the difference between holding it at like my chest level versus throwing it from above my head, it made a difference in the splash. So if we are going really far away and smashing into things, it's going to create even larger craters. And these mega craters, that's what we see today when we look up at the moon. Some of the biggest craters that we see up there were formed like 6.8 million years ago from giant asteroids, because there was a ton of solar storms back at that time, and they were just being littered by rocks. Now, Earth is a little bit different from the moon in a lot of ways. And one way that's so important when we're thinking about asteroids and craters is our atmosphere. See, when rocks hit our atmosphere now, we see them as flying stars, right? You ever seen a shooting star? Those meteors, meteorites, whatever you want to call them, they are little bits of rock and space debris that enter in our atmosphere, and they are incandescent. They glow because they are burning up. So as they're traveling down, they're like, poof, I'm on fire, and they burn up most of the time before they ever hit the ground. Or if they do, they're very small, so they don't do the kind of damage. Now, the moon does not have an atmosphere. There's nothing there to stop those rocks, to slow them down, to burn them up. So they just hit wham, full force every single time. Now for this experiment, I'm going to use a pan, and it could be any depth. If you could make that deeper, definitely go for that. It will look so cool. But this is what I have cleaned that's not, mini sized. And you're going to need flour or cocoa powder or any two colors. I'm going to use some pancake and waffle mix, and I'm going to pour it onto my pan. Kind of smooth it out a bit, just like that. I had planned on doing this activity on a much larger scale outside, but that would turn goopy. 10/10 do not recommend. So I've got it pretty much patted out, and this part's optional, but I'm going to add a little bit of flaxseed for some texture because I'm making the surface of a planet here. So So milled flaxseed is kind of like a light dust. And then I'm going to sprinkle my cocoa on top. This works so much better if you have a sifter. But again, I don't have mine handy. So I'm gonna sprinkle, sprinkle, sprinkle. I'm using the cocoa just because they're very different colors. If you're making a version that you're not going to eat later, because I am going to eat this later, then you can use mica powder or glitter, kind of any powder you feel like. Okay, now I have a nice brown layer. So I'll have some small objects. You can use marbles or ping pong balls. I have some fruits and nuts. They are different sizes and different weights and different shapes. Now with my baking sheet outside, this is where I'm going to make my predictions. What do you think is going to happen? And I drop these onto the surface of my planet. Standing about a meter over the top, they have a little half cranberry. Not much. What about an almond? Check that out. Now, what if we give it a little bit more force? Watch how the surface of our planet is changing. See the little craters of where it fell in? Now, we can see when we remove our asteroids themselves where they went in, as well as some of the damage that went around them. So like over here, that's where our asteroid hit. We can see the Earth underneath it, under our first layer. And this part over here expanded outwards because the crust needed somewhere to go. Now I've smoothed out my planet a little bit more. Let's say we have a full solar shower like the moon went through. And that means lots of high intensity impacts all at the same time. What happened to our surface? It's going to keep getting more and more destroyed. See how the craters kind of start to run into each other? And then our largest craters will continue to change the way that the surface of this planetary body looks. If you have a deep container, especially if you have a lot of flour or a lot of different kinds of flowers, you'll be able to see even more of how those craters are actually 3D. Now it's your turn. Make a model to show your understanding of asteroids. It could be flat on paper. It could be flat with an experiment. It could be a rounded experiment. It could be a big ball that you hang from the ceiling, whatever it is. I would love to see what you think is around your planet. Do you have a lot of space to breathe? It's all up to you.